Modern internal combustion depends on a delicate interaction between fuel and atmosphere, a balance often disrupted by a single overlooked component within the intake tract. 11 specific warning signs frequently signal a deteriorating throttle body, yet many drivers remain unaware of these indicators until their vehicle leaves them stranded. Motorists often misdiagnose these symptoms, pointing toward aging spark plugs or a failing fuel pump, leading to expensive repairs that fail to address the root cause. Since the mid-1990s, onboard diagnostic protocols have monitored this key airflow pathway with extreme precision. At the heart of this system sits a simple butterfly valve, a circular metal plate that regulates how the machine breathes. Even a microscopic layer of debris within this housing disrupts the entire combustion cycle. When oily residues and combustion byproducts coat this metal gate, the powertrain begins to starve for oxygen, forcing the onboard computer to react unpredictably. Fortunately, identifying these cues early allows for a simple restoration of performance through targeted maintenance. To grasp the complexity of this component, imagine the large plastic or rubber ducting leading from the air filter box toward the top of the motor. At the end of this duct, positioned between the intake tubing and the engine manifold, lies the throttle body, containing a rotating disc that modulates the volume of air entering the cylinders. Depressing the accelerator sends a command, either via a mechanical cable or an electronic signal, to pivot this disc. This single plate manages virtually all of the power unit's breathing capacity. While this mixture generates the energy required for movement, daily operation exposes the intake to a cocktail of oil vapors from the crankcase and soot from the exhaust gas recirculation system. This mixture creates a stubborn, tacky film. Over several thousand miles, this layer alters the physical dimensions of the air passage, causing the car's management system to struggle with fuel delivery calculations. As a result, the vehicle loses its once crisp responsiveness. Beginning our list at number 11, delayed acceleration represents a common frustration, where the driver encounters a notable pause after stepping on the gas. Pressing the pedal should result in immediate momentum, but instead, the car remains stationary or rolls forward sluggishly for several seconds. Drivers often describe this as a dead pedal sensation, where the connection between their foot and the motor feels severed. This lag stems from physical resistance within the intake housing, as the internal flap must fight against sticky carbon buildup and mechanical friction to swing open. Because the initial burst of oxygen arrives late, the cylinders cannot generate enough force to move the vehicle's mass instantly. Such a delay compromises safety during critical maneuvers, such as turning left across oncoming traffic or merging into a fast-moving lane. Motorists find themselves second-guessing their car's ability to navigate busy intersections safely. Moving to number 10, engine stalling manifests as a concerning symptom where the powertrain ceases to operate entirely during deceleration or while idling. Imagine approaching a stop sign. As you lift your foot and the revolutions drop, the motor suddenly goes silent. This happens because the butterfly valve must maintain a microscopic gap to allow idle air into the system when the pedal is not depressed. If grime narrows this gap, the volume of incoming air falls below the volumetric threshold required to maintain combustion. The tachometer needle drops below 700 revolutions per minute before the rotating assembly comes to a complete halt. While the car might restart after a few attempts, the underlying obstruction remains, meaning the stalling will likely recur at the very next stoplight. This creates a stressful environment for the driver, who must constantly monitor the tachometer to ensure the car stays running. At number 9, rough idling introduces an intrusive vibration that permeates the steering wheel, seat frames, and dashboard. Under ideal conditions, a healthy motor maintains a steady, rhythmic hum while the vehicle remains stationary. However, an obstructed intake forces the computer to constantly hunt for a stable speed. You might notice the RPM needle bouncing erratically up and down between 500 and 1,000 cycles. This physical shaking originates from the uneven power output of the cylinders, as they suffer from unstable combustion and misfires at low speeds. Such constant oscillation creates a choppy, uneven harmonic that stresses the rubber motor mounts. If left unaddressed, these vibrations eventually fatigue the chassis components, turning a minor intake issue into a broader mechanical failure that necessitates the replacement of expensive vibration-dampening parts. Number 8 involves sudden speed surges, which occur when the vehicle unexpectedly lurches forward without additional input from the driver. This creates a situation where the car seems to have a mind of its own, accelerating while your foot remains steady on the pedal. These surges happen when the internal flap, having been slightly stuck, suddenly snaps open further than intended to overcome a physical obstruction. A sudden rush of air enters the manifold, causing a spike in horsepower that forces the driver to apply firm brake pressure. This erratic behavior often happens at low speeds, such as when navigating a parking garage or crawling through heavy traffic. The unpredictability of these jumps indicates that the electronic motor governing the valve position is struggling to maintain a consistent angle against internal friction. Landing at number 7, a decline in fuel economy serves as a quiet but persistent drain on a driver's finances. You might find yourself visiting the service station every 5 days instead of every 7, even if your driving habits have not changed. This reduction in airflow actually prompts the car's management system to detect the drop in incoming air mass and automatically reduce fuel delivery to maintain the correct stoichiometric balance. When the intake cannot provide a clean, unobstructed flow, the computer limits the injected fuel to keep the mixture from running too rich, which instead restricts the engine's ultimate power output. While this restriction does not greatly impact the fuel economy of modern, fuel-injected vehicles, it severely degrades the engine's acceleration performance. Much of this expensive gasoline goes to waste, exiting the tailpipe as unburnt hydrocarbons rather than being converted into forward motion. At number 6, high or unstable idle speeds appear on the dashboard tachometer while the vehicle sits in park or neutral. While a standard idle usually hovers around 800 revolutions per minute, a malfunctioning intake path can cause this number to climb toward 1,500 or higher. The powertrain might sound like it is racing, even though your foot is nowhere near the accelerator. This high-speed spinning occurs when the throttle plate fails to seat correctly in its resting position, allowing extra air to bypass the intended barrier. Because the system detects this extra oxygen as a lean condition, it increases the fuel delivery to restore the proper air-fuel ratio. Beyond the annoying noise, this constant high-speed operation generates excessive heat within the cooling system and puts unnecessary wear on the internal bearings and piston rings. Moving to number 5. Engine hesitation manifests as a temporary pause or delay when opening the throttle, which can lead to physical stumbles or hiccups during acceleration. The vehicle might jerk forcefully several times as you attempt to reach highway speeds, resembling the sensation of a transmission slipping. This bucking happens because the air-to-fuel ratio is swinging wildly between two extremes. For a fraction of a second, the motor starves for fuel, leading to an immediate imbalance where there is too much air relative to the fuel in the cylinders. These rapid-fire fluctuations create an uneven power delivery that feels like the car is tripping over itself. Drivers notice this most during stop-and-go city driving, where constant transitions between idling and accelerating expose the intake's inability to move smoothly through its range of motion. Number 4 involves the appearance of dark smoke from the exhaust, providing a visual confirmation of an imbalanced combustion cycle. If you see puffs of black soot in the rearview mirror when pulling away from a stop, the motor is likely burning an overly rich mixture. This dark vapor consists of partially burnt carbon particles that form when there is insufficient oxygen to consume the injected fuel. Beyond being an environmental concern, this soot coats the internal surfaces of the exhaust manifold and the oxygen sensors. Eventually, this heavy carbon load travels downstream to the catalytic converter. This expensive emission control device can become clogged by the soot, leading to a much larger repair bill than a simple intake cleaning would have required. At number 3, failed emissions tests serve as a bureaucratic reminder of an intake problem. Many regions require periodic inspections, where the vehicle must meet strict standards for tailpipe pollutants. When the throttle plate is obstructed, the resulting incomplete combustion raises the levels of carbon monoxide and unburnt hydrocarbons well beyond legal limits. Even if the car feels relatively normal to drive, the diagnostic computer at the testing facility will detect that the fuel trims are outside of the acceptable window. A failure report prevents the driver from renewing their vehicle registration, turning a mechanical nuisance into a legal hurdle. Resolving this issue is the only way to restore the chemical balance necessary to pass the inspection and keep the car road legal. Number 2 is the activation of Limp Home mode, a protective software state designed to prevent catastrophic hardware failure. When the computer detects that the electronic throttle motor is no longer following commands accurately, it illuminates a yellow wrench or reduced power icon on the dashboard. In this mode, the car's speed is often electronically capped at 20 or 30 miles per hour, and the accelerator response becomes extremely sluggish. This failsafe exists to ensure the driver can pull over safely without the motor revving out of control or stalling in a dangerous position. While frustrating, Limp mode is a protective state triggered by a wide range of critical faults, which frequently includes a breakdown in electronic throttle communication, requiring immediate mechanical intervention. Finally, the number 1 warning sign is a crank but no start condition, which renders the vehicle completely immobile. You might turn the key or press the start button and hear the starter motor spinning the engine over vigorously, but the combustion process never actually begins. This total failure occurs when the throttle plate becomes physically stuck in the fully closed position. Since a motor requires a specific volume of air to ignite the initial spark, a sealed intake makes starting physically impossible. No matter how much fuel the injectors spray or how strong the battery is, the lack of oxygen prevents the first fire from catching. This leaves the driver stranded, often requiring a tow truck to move the vehicle to a repair facility. The encouraging news for car owners is that these symptoms rarely necessitate the purchase of a brand new throttle body, which can cost hundreds of dollars. In many instances, a simple cleaning procedure using a specialized aerosol solvent can resolve the issue entirely. These cleaning agents are designed to dissolve the stubborn varnish and carbon without damaging the sensitive electronic components or the internal coatings of the housing. By removing the intake ducting and using a lint-free cloth dampened with the cleaner, a technician can wipe away the black residue until the shiny metal surface reappears. This restores the factory-specified clearances, allowing the butterfly valve to move without friction once again. However, caution is required. Modern electronic units should never be forced open manually, as this can strip the delicate plastic gears inside the motor housing. Beyond the physical cleaning, many modern vehicles require a throttle relearn procedure after the service is performed. Because the computer had previously learned to adjust for the dirt buildup, it must now be taught the new, clean resting position of the valve. This is often done through a specific sequence of ignition cycles or by using a diagnostic scan tool. Performing this maintenance every 30,000 miles ensures the intake remains clear and the motor stays responsive. Taking these proactive steps saves motorists from the stress of unexpected stalls and the high costs of unnecessary sensor replacements. Keeping the intake tract clean is one of the most effective ways to ensure long-term reliability and a smooth driving experience. By paying attention to these 11 signals, you can maintain your vehicle's performance and enjoy peace of mind on every journey.